Picture this. You just bought a shiny new electric vehicle. You're feeling fantastic about saving cash at the pump and doing your part for the environment, right? But then, fast forward 6 months, your range has mysteriously plummeted, the cabin hums like a cheap desk fan, and your tires completely bald. What gives? Well, you basically treated a spaceship like a golf cart by throwing standard tires on it. Welcome to today's Explainer. We're diving deep into the hidden physics of why electric cars absolutely devour standard tires and why EV-specific rubber is a completely different beast. It's a wild story of weight, torque, silence, and chemistry. Let's get right into it.
Now, I hear this all the time. People insist, come on, rubber is just rubber. But look, an EV is not just a quieter gas car. Not even close. Because of their completely unique physical traits, EVs turn an ordinary drive into absolute torture for standard tires. We're talking faster wear, stolen battery range, and completely wiping out those fuel savings because you're forced back to the tire shop way ahead of schedule.
Here is our quick roadmap for today. 1. The great EV tire myth. 2. Handling the heavyweight. 3. Taming instant electric torque. 4. The physics of silence. 5. Rolling resistance and range. And 6. The true cost of rubber.
Section 1. The great EV tire myth, devouring standard rubber. Okay, the biggest misconception out there right now is that throwing regular tires on an EV is just a tiny sacrifice in ride comfort. No way. It's actually a massive efficiency killer. Slapping the wrong tires on your EV can drain up to 15% of your battery's range. Think about that. The tires you bought to save a few bucks up front are quietly, literally eating away at your car's efficiency mile by mile.
Moving to Section 2. Handling the heavyweight, the mass of 2 grand pianos. So the first physical pillar we really need to wrap our heads around is weight. Take an EV like the Hyundai Ioniq 5. It weighs a massive 400 to 600 kilograms, more than a gas SUV of the exact same size. To put that absurdity into perspective, it's like driving around with 2 full-size grand pianos permanently strapped to the roof. That immense, constant mass absolutely punishes the tiny patches of rubber that actually touch the road.
Let's look at the actual physics here. If you put an 800-kilogram load on a regular tire and accelerate hard, it deforms by 12.1 millimeters. Worse, the sidewall heats up to a scorching 90 degrees Celsius. I mean, it literally bakes the rubber, instantly cutting its lifespan in half. But take a highly engineered EV tire, like the Michelin Pilot Sport EV. Under that exact same load, it deforms by only 5.2 millimeters. It holds its shape like an absolute champ despite that immense pressure.
So how do you actually spot these heavy-duty tires in the wild? Look closely at the sidewall markings for the letters XL, which stands for extra load, or HL for high load. The inner carcass of these tires is woven with super high-density cords. Honestly, they function almost like steel cables in an elevator, just to keep the tire from collapsing under the car's weight. And practically speaking, you have to pump these heavyweights up to 3.0 to 3.2 bar of pressure, which is way higher than a standard car, just to prevent weird, localized wear patterns and keep you from losing range.
All right, Section 3. Taming instant electric torque, the physics of grip. This brings us to the second physical pillar, torque. Look, electric motors don't have to wait for gears to shift or an engine to rev up. They dump instantaneous, massive power straight to the wheels the second you tap the pedal. And that immediate rotational force, it'll shred ordinary rubber in no time. 1,020 Newton meters of torque. That is the raw, unadulterated power that erupts from a Tesla Model S Plaid the millisecond you hit the accelerator. Put ordinary tires up against that, they just surrender to the chaos. They screech, they spin out, and they totally relinquish control. You absolutely need specialized equipment to translate that kind of raw, instant force into actual forward momentum, without leaving a puddle of melted tread behind on the asphalt.
To fight this, EV tire makers are using literal aerospace-level engineering. First, they stretch out the tire's contact patch by 3.5% just to get more physical rubber on the road. Continental, for instance, uses a green chili compound. It embeds nano-engineered ceramic microspikes right into the rubber matrix to literally claw into the wet asphalt. This drops tire slip down to under 2%. Plus, they use dual-layer treads that can actually trim the emergency braking distance of a 2.4-ton EV by a full 1.8 meters. It's just phenomenal engineering.
Section 4. The physics of silence, muting the cabin hum. Let's talk about our third pillar. In a traditional car, you have this roaring combustion engine that naturally drowns out the sound of the road. But in an EV, that engine noise is completely gone. And without it, the sound of standard tires rolling over rough asphalt becomes deafening inside the cabin.
Check this out. At just 60 kilometers per hour, standard tires kick out about 75 decibels. Guys, that's literally as loud as running a vacuum cleaner in your passenger seat while you drive. But EV-specific tires, even at highway speeds, drop that noise down to around 64 to 67 decibels. That feels way more like sitting in a quiet office. And dropping just 6 decibels is a game changer. Studies actually show it can lower driver fatigue by up to 40% on a long road trip. So how do they pull off this physics of silence? It's actually brilliant. They line the inside of the tire with a specialized polyurethane foam. Continental calls theirs ContiSilent. This foam acts as a massive sound dampener. It absorbs the road vibrations and completely neutralizes the exact air resonance frequencies that our human brains find so annoying. The end result? Slashing cabin noise by up to 9 decibels. Part 5. Rolling resistance and range, the tug-of-war with physics. Our final physical pillar is this constant battle between the tire gripping the road to keep you safe and the tire letting the car glide to save battery. A detailed study out of Chalmers University found that rolling resistance accounts for roughly 29% of an EV's total energy losses. To put that 29% into perspective, EV-optimized tires consume around 269 watt-hours per mile. Conventional performance tires, they guzzle 290 plus watt-hours per mile. If you take a 300-mile road trip, those standard tires are stealing enough of your battery's energy to power a mid-size refrigerator for a full 24 hours. The secret sauce behind this insane efficiency is all in the chemistry, specifically silica. Your standard summer tire uses maybe 15 to 20% silica. EV tires crank that all the way up to 35%, and then they weave aramid fibers directly into the tread. This special chemical matrix stiffens up the tire to drastically cut down friction and drag, while somehow miraculously keeping your grip on wet roads.
Section 6. The true cost of rubber. Real-world trade-offs. Okay, time for a reality check. We're talking about highly engineered aerospace-grade solutions wrapped up in rubber. And naturally, that level of tech comes with some serious compromises when it comes to longevity and your wallet.
A study by Vulti breaks this down, and it's a bit of a tough pill to swallow for consumers. Because of the extreme weight and instant torque we've been talking about, an EV tire lasts, on average, just under 29,000 kilometers. Compare that to over 40,000 kilometers for a traditional gas car. Plus, you're looking at dropping around 240 euros per EV tire, compared to maybe 150 euros for a standard one. The reality is, if you drive an EV, your running costs for rubber are just undeniably higher. So what's the bottom line here? The research puts it perfectly. EV tires aren't necessarily better. They're solving equations regular tires ignore. Yes, they cost more upfront. And yes, they wear out faster. But this specialized EV rubber is an absolute structural necessity. It's not some clever marketing gimmick. It is pure, unavoidable physics. Look, if you slap standard tires on your EV, sure, it'll technically drive. But eventually, the sheer weight, the instant torque, and the demand for silence are going to overwhelm them. Matching the right, highly engineered technology to your specific machine is really the only way to unlock its true potential. So next time you see an electric car silently gliding past you down the street, ask yourself, what invisible, violent battles are those tires fighting right at that exact moment? We really hope this simple breakdown of the complex physics inside EV tires helped clear things up for you today. Thank you so much to our brilliant listeners for tuning in. Keep learning, keep questioning, and we'll catch you on the next explainer.